Okay, this video is to illustrate watershed delineation for Module 1 of DES 601. The video is intended as a supplement to the actual face-to-face training. The way I'm going to illustrate it is I am going to, on the screen, do what I would normally do on a piece of paper. I'll be using screen tools and stuff instead of an actual pencil, but I believe you'll get the idea. Okay, so in the watershed delineation, one of the first things that the guidance or the New Hampshire method says to do is identify the point of interest, and then radiating out from that attempt to identify nearby high points which decide kind of which direction water would go relative to the point of interest. Okay, so here's a point of interest right here. There's a high point right there. We will shrink that so that it's a little bit more realistic. Moving on up, there's a high point about there. There's a high point right here. You see how this branch drains into the reservoir coming up that way. So that high point's going to be included. That high point's going to be included. That high point's going to be included. Now this drainage goes down there. That drainage way goes down there. You see these drainage way here doesn't go to our point of interest. So this ridge right along there where the cursor is moving is watershed divide, or now this drainage does go, so that high point right there is part of the watershed. We have a drainage coming down that way, so that does not go to our point of interest. We have a drainage going upward, which does go to our point of interest. So this right in here, even though there's a highway there, which probably interferes with the flow north and south, we're going to go ahead and include that in this particular example, just to get the idea of using topography to help us find our drainage area. Now this high point here, water drains down that way or down that way. There's a saddle point right about there where it goes north or south, so I'm going to include that high point right there that I've just marked. I'm going to bring in another one right about here. Now we see this drainage goes downstream of the point of interest, so that's about the best we can do in terms of high points. The next thing I would do as an analyst is I would alternately look at the high points and the topography pattern and figure out how to draw a boundary line between where water would go into this reservoir area and where it would not. I'm going to rapidly do that using just this scribble tool. This ridge line right here goes down to the top of that dam. So roughly along there is a divide. Okay, so sticking with that theme, I have a about like that. And so what I'm doing is I'm sketching between each of the high points the ridge lines that divide up the watershed. Now my gut is this road is built on, this dirt road that I just traced is built on the high point. So without actually being able to go out there and examine it, I can't really tell. Now I've noticed, see this drainage right here, I've actually encompassing area that does not get to my outlet. So I'm going to have to delete that. That high point is not part of my drainage pattern. But that ridge line right there is. Now let's go ahead and redraw the drainage area. It runs down this ridge, goes something like that, down this ridge line. That's much better. Okay, and I hope you're picking up from the video that, at least when doing it manually, this is a, it's not terribly difficult, but it is substantially a trial and error process. If we do it automated, essentially what the automated does is it takes this picture, it superimposes a grid system based on a digital elevation model, interpolates in that until those grid cells are representing comparatively small areas. 1 square meter is now fairly conventional resolution in an urban area. We're going across an airport here. And in the rural area, 10 square meters, so basically a 30 by 30 foot square is identified. Okay, and that's more or less how we would manually delineate a drainage area. And then depending on the level of accuracy that we're after, we would refine those lines as necessary. For the purposes of this introductory to hydrology class, that's a pretty good delineation. We see that this drainage area is roughly about 1, 2, 3, 4, 5, 6, 7 and some change square miles, and we could use measuring tools to find that out. But that's the subject of another module in the training program. Okay, so the second example I'm going to do without much discussion in a subsequent video. Okay, this video is the second example watershed delineation, and the main thing about it, it's the same as the first one, except we're now going to delineate the area associated with this point. US 87 is running east-west, and essentially the drainage crosses most likely in a culvert, probably a box or maybe a multi-barrel circular. What's going to be slightly different here is it's fairly plausible that the highway itself serves as a partial boundary to flow. So while we're going to be concerned with the topographic contribution, we're also going to take into account the existence of the highway, and essentially you'll probably see what I mean when I go ahead and start to draw it up. Okay. So we'll try to stick with the method before, which is to find some high points. Let me go ahead and basically grab a blank marker, and we have a drainage path coming up that way, and it goes up kind of to this place, so those are going to be a common high point. It looks like we have a little tributary coming up this way, and then it gets into this sort of open undifferentiated area. Notice the shape of the contour line right there. It's almost perpendicular at the highway contour line intersection, and so that's what's a clue to me that in all likelihood the highway itself is serving as a way of directing water to a culvert that's likely to be here, and there may be others along here. Again, our goal here is to get a little bit of experience delineating a watershed. So with that in mind, we know that this is a common high point, And in fact, that drains this way, and I'm going to make a guess that there's likely a culvert right there. So this ridge line right there is what divides those two flow patterns. So let me get started drawing along that ridge line. So I think that's a part of the boundary. Let me go ahead and grab me a high point, put that there. So I think there's some high point right about in here, and then this drains down to my outlet, so I'm going to actually just put a high point right there and use that to help me guide my drawing. So I'll continue on. It probably goes up along like that. And then we'll come down and join these. And then we follow the highway to the outlet. And on the other one, and that would be my best estimate of the second drainage area. Now as I'm looking at it, I've noticed I've just grabbed that little bit of drainage, and again my gut feeling is there's probably a culvert there. So I've just got this little sliver of too much drainage area, so let me go ahead and remove it and redraw it. And that's what I mean by the somewhat trial and error nature of this process. If we do it automated, it's certainly something this size, it probably takes more time to set up the automated technology than to do it by hand. But once things start to get big, generally speaking, automated approaches are much more time economical. It's in our best interest to maybe do a manual or two on those automated areas to be confident that we're getting about the same numbers. Usually by manual or automated, you're within a few % of each other. And if there's a vast difference, then there's some conceptualization mismatch there, and you need to address it. Okay, the exercise that you're going to do is going to be concerned with that point, and the drainage is this stuff coming down this way, and this one. And that concludes the second example video.